Thank you. Should I wait or? Good. Hello, I am Sorin. I lead the engineering team at Bunnyshell. We're a company who aims to provide a better experience for developers and also to help development teams move faster in their journey towards launching the products. So before we dive into what today's session will be about, let's see. Can you help me with this, please? The clicker doesn't work. Thank you. So let's see what an environment actually is. So basically an environment, an informal definition is that it's all that's needed to run a platform. Basically you have the underlying infrastructure, you have configurations, you have all the applications, services, databases, cloud resources, and whatnot. And on top of these, you have the workflows, which put it all together. Basically, they dictate how the environment gets deployed and then updated. In today's session, we will discuss some challenges which development teams are facing nowadays. We will see why this happens, how a relatively new concept called environments as a service can help solve these problems. And don't worry, it's not going to be all theoretical. We're going to see a practical implementation as well. Still doesn't work. OK, so what are the issues with the current landscape when it comes to software development teams? First of all, there are simply not enough environments to test on. And this is a huge challenge for organizations, not only when they need to test parallel features, let's say, before they release them to production, but also for developers which are developing on local environments, which we'll see are very different than staging and production. And therefore, they would actually need some of these environments to dev test on while they are still working on a certain feature, not only towards the end of the project. Second, we have most organizations owning like a fixed number of environments, 2 or 3 or 5. But either way, it's very limited and a small number of environments. And these certainly cannot accommodate for the needs I specified earlier. This causes for slow iterations, which in turn demotivate people, disengage them, and this leads to poorer collaboration overall and a lower morale for people. These environments, which are fixed and running 24/7, are also not very cost effective because they're used like 45% of the time. In fact, clicker still doesn't work. I will do a thumbs up to change the slide from now on. OK, thank you. So we have, I already tapped this a bit. We have a lack of consistency between environments. Development environments are very different than staging and production ones. They usually mock or simulate other services or dependencies. And although this might seem like a pretty minor setback, for large organizations which have cloud-native applications, this is like a really huge problem because they find out in the latest stages of testing and development that their code doesn't run as they expect it to be. Besides this, there's also a very, very big problem for developers because their focus is shifted from the applications, like having direct productive activities there and bringing value to the product in, I don't know, coding, architecting, reviewing peers' code, writing automated tests, and so on, the core activity of a developer. And this focus is taken towards troubleshooting issues on staging environments, and these are mostly due to configuration mismatches. So this is a very, very big problem for most developers, especially in larger organizations. Also for larger organizations, okay, so it seems like we got a working clicker. Thank you. Also for large organizations, we have these configuration gaps which can in turn cause security incidents and therefore compliance issues for these organizations. All of these lead to slower development cycles, which cost organizations very, very much, both in direct costs as financial losses and in turn with employee turnover, because unhappy people move on and try to find a better place ultimately, right? So what causes these issues to appear? Well, we have more and more complex applications. We have very diverse technologies, not to say that they're all over the place with a lot of languages, a lot of versions, frameworks, and all of these combined, basically. Unfortunately, replicating these configurations is not entirely or not at all automated sometimes, and this leads to other issues which I've discussed a bit earlier. Documentation, especially the internal documentation, is usually a bit behind, or it doesn't get updated at all sometimes. And the biggest problem, in my opinion, is that these environments have state, because state invites drift to happen. So this is how environments actually diverge from one another. And it seems that we also have a theory behind why this happens. Large and complicated systems, when dealing with these four properties, meaning variability, interconnectivity, state, and irreversibility, are very, very hard to keep in check. And for the variability and interconnection, there's not much we can do, unfortunately, because all the systems are obviously interconnected. And for the variability part, we also use packages and libraries which are outside of our direct control. So what we can do here is to eliminate state, which will also eliminate the need for reversibility, therefore putting us, again, in control of our systems. Environment as a service, the topic of today's discussion. What is it, in fact? Well, the definition says that it's a cloud computing service model. Basically, what happens is you can, as a developer or as a person working within a development team, you can create your own staging, a replica of it, within minutes, or you can go and create an environment for collaborating with a peer or with a stakeholder, just like that, by running a CLI command or by running a few clicks within an UI. This is what environment as a service is all about. It's about giving developers control and autonomy, for them not to depend on third parties, not to raise tickets and wait for weeks until a new environment gets spun up. Basically, what environment as a service is trying to achieve is to streamline the whole development process across its all steps. And it does that by eliminating environment-related bottlenecks. It also provides us with the much-needed consistency and therefore eliminates rework in the final stages of development. And as I said, it allows developers to focus on what they do best: code, architect, design, review, and improve performance. These problems are not new, but let's say the bubble burst quite recently. Organizations, large organizations especially, have sorted to figure things out and kind of solve these issues from various angles. And therefore, these concepts appeared. I'm not going to go deep into them now. I'll have a slide later on for each of them, but it's all about having a service catalog, an internal developer platform, working with ephemeral environments, and working with cloud development environments for remote development. Basically, environments as a service brings them all together under a big umbrella, let's say. So before we actually look at those case studies, what does the market do? What are the leading analysts saying about this? So first of all, Gartner recognized very recently, it's 2 or 3 weeks old, this news. It included cloud development environments in their emerging technology cycles for this year. And this is really a big thing because it recognizes the market trend towards developing directly in the cloud. They also predict that in 3 years' time, 60% of the builds and deployments will happen in the cloud, also for developers, which is kind of unimaginable right now or 1 year ago. Also, almost 60% of the C-suite level considers developer experience to be critical, and this is a huge shift from 3 or 4 years ago. McKinsey has a study showing that organizations which have a higher developer productivity outperform the market by 4 to 5 times, which is really huge. So the ability to move fast and iterate in a market gives them the essential tools. Of course, not just execution, rapid execution is fueling their performance. They also do rapid execution because they have good processes and they discuss with their users or customers. And a very interesting fact, at the end of previous year, Redmonk predicted that 2023 will be the year of the cloud development environment, and so far it seems like they pretty much nailed it. This is the chart for the hype cycle published by Gartner. My apologies, it's quite hard to distinguish here. We have both the internal developer platform and the cloud development environments highlighted with red arrows. The internal developer platform is expected to mature in 2 to 5 years, while for cloud development environments, it's more like a 5 to 10 years waiting time, predicted waiting time. There are some reasons, some good reasons for which Gartner included cloud development environments in their hype cycle, and in fact, it's nothing new here. We all know it. Cloud is being more and more used. Stacks are becoming more and more complex. We are working remotely more than ever before. Therefore, we need standardization, we need enhanced security. And probably one of the biggest things here is that current workflows are repository-centric. What does this actually mean for applications or for environments? It actually means that, let's take, for example, GitHub Actions or GitLab pipelines, right? It runs on a repository, and it means that ultimately a component of an environment will need to orchestrate the deployment of the whole environment. And this isn't quite natural, and people using this concept have seen this and have pushed towards new concepts. How to get environment as a service into an organization? So besides the change in technology, which is inherent, there also needs to be a change in the way you think, in the way you approach environments, because environments as a service truly unlocks a great of potential, allowing you to create parallel environments and work like really efficient in a multitasking environment. As usually, you should start with a big pain to have motivation and to see the potential results there. And you should consider whether you need to build it in-house or buy a platform which is more mature. We are developers, and ultimately we love to build, right? So this would be the first reaction for any developer. But there are less than expected results for most companies who have already tried this, because the cost of maintaining the platform is quite high after you initially build it. So whenever you're set out to build a new platform, you should clearly define what you need from it, right? That's why we at Bunnyshell started by defining a set of principles on which the platform should fulfill towards. We wanted to manage environments through code, so the change management is easy, so it's traceable, so it's auditable. We wanted to have self-service, because ultimately this is the promise of environments as a service, right? We wanted developers to be able to assemble environments from building blocks, so they can create also partial environments, and these need to really be efficient. I would say that flexibility and extensibility are mandatory for any product that looks towards adoption. Basically, you need to meet teams where they are. You need to leverage what they already have today, not cause rework in the environments as a service implementation process. So going back to what an environment looks like, this is the previous scheme somewhat applied on Bunnyshell concepts. This is how Bunnyshell models it. We have components for describing applications, services, databases, and resources. And these components can be anything from Docker Compose components, plain Docker images, Kubernetes manifests, Helm charts, or even custom scripts. So if none of the previous categories fit into your need, you can always script your way through it. Variables at various levels, like project, environment, and component, can be used to configure these environments and link them together. And the workflows control how the environment is being deployed, started, stopped, or eventually deleted. This is how an environment looks like in Bunnyshell. Basically, you have the components on the left side, you have some deployment logs on the right side, and you can also see resources which were created by every component. You can see resources created in Kubernetes, for example. And in this example on the right side, we have live streaming logs from the container of the application. Having this really fulfills the need for self-service for developers, because developers don't need access to Kubernetes anymore. They can just use a tool and get all their needed information, like deployment logs, pipeline logs, real-time application logs, and so on. Very briefly, this is more or less how a component looks like. This is a Docker Compose-based example. I'm going to try and walk you through it. I know that it's not really very visible. Basically, you only need to specify the repository, the branch, and the path from the repository, which are the Git coordinates, the hosts you want to expose, and besides that, it's fully Docker Compose compatible. This doesn't have a laser, but anyway, it's kind of this section here, which is fully Docker Compose compatible. It supports environment variables, port exposure, volumes, and so on. So another very, very quick example is for Helm charts. It's somewhat the same. It has the same Git coordinates, right? Repository, branch, and path. You need to define a runner image. Basically, this is a container image on which the Helm install will actually run. And then you have scripts which you can configure for deploying, for starting, stopping, and destroying the environment, which is basically the section here. Here, you usually have a plug-and-play system from what you already have today. So if you have a CI/CD, a pipeline that's already set, you can reuse those scripts and basically copy and paste them within Bunnyshell. Usually, there are just a few tweaks, like removing hard coding needed. But it's very transparent and very controllable for developers, which is what we actually wanted. We're going to go into the use cases section of the presentation now. First one is the service catalog. Basically, the service catalog helps introduce order within organizations, especially within large companies. You are able to document which teams owns which service. You are able to provide a template for spinning other environments, identical environments. You are able to see the documentation, and you are able to basically have traceability above all on this process. This is how environment templates look like. Basically, you can have multiple sources with multiple templates. The templates are stored in Git, so they are by design auditable and versionable. And merging work together is like really easy because you can leverage the Git default mechanisms. And this is how a developer would actually see a template. On the left-hand side, we have some metadata like text, structure, description, and so on. And on the right side, it's plain old documentation. It can be written from scratch and customized entirely. You can also put links with other applications here, or like login data for the platform after its deployment. You can customize it fully. This is an example for how the interaction with the CLI would look like. In the top part, we have a list command for the templates. And in the bottom part, we have an environment created out of a template. So it's that simple to create a new environment from a template. If you notice, we have the status draft on the last line. I'm going to get into this a bit later and show you how you can also deploy the environment. Next use case is the internal developer platform. Basically, this is the most comprehensive use case of all. It's the liaison between all other concepts. It allows you to control an environment's lifecycle completely, from its creation, deployment, replication, which is really important, replicating environments, and ultimately the destruction of the environment and cleaning up of the resources. The test environment management platform is somewhat the same as an IDP, but it's more geared towards testing. So it's, if you want, somewhat of a subcase of an IDP. And this is how an environment listing would look like in a project. I hope you can see there's a drop-down menu open, which has actions like deploy, stop, or clone. These are literally one-click actions that can be performed from the UI and also from the CLI. We'll see in a bit. And this is how a pipeline or workflow would actually look like. Basically, it's a pretty standard pipeline. It's organized into jobs and steps. You can see the logs, and everybody's everybody's happy for the self-servicing part. And this is the example for how you can interact with the environment. So you can list environments, you can clone an environment, and then you can basically deploy it. The last piece shows a work-in-progress deployment. And here at the top, we have deployment who has been already completed. So when it ends, it also outputs the public URLs that you chose to expose for your applications. Obviously, this is in human-readable format for developers to interact with, and it's run synchronously, but you can choose to run it asynchronously, and if you need to integrate, I don't know, within a pipeline or another workflow, for example, you can choose the JSON output, so you can have structured data to parse and integrate as input for other jobs you may have running. And lastly, there's the delete command. So basically, we saw how using the CLI, you can create an environment, deploy it, and then delete it. So how about keeping these environments up to date? Because we touched base on that. Well, it's just literally a flip of a switch. So we have an auto update here in the lower part of the screen. It's a setting which leverages the Git integration and Git webhooks, and it will trigger a deployment for the components who have been updated. Next topic on the list is cloud development environments. So what is actually a cloud development environment? It's an environment on which developers work instead of their local environment, and it's useful for situations in which local development just doesn't cut it anymore. And this could be for several reasons, like maybe laptops are not powerful enough to run all the services that you need at the same time, or you have frequent defects caused by mocking or simulating cloud-native services within your application, but the services actually behave a bit different when put to the test in the real world. Or another pretty frequent use case is due to compliance or regulatory issues where you cannot have any data or code stored locally. So you would actually need to have it only in the cloud. This is how Bunnyshell implements working with remote development. It's as simple as defining a config, we'll see that in a bit, and then running a command. The command is ran is just Bunnyshell remote development up and specify the ID of the component. It will modify a bit the Kubernetes manifest which you have deployed. Not going to get into too much detail here. And then it leaves you in a shell within that container so you can execute other commands like build or installing assets, I don't know, whatever is needed for the particular application. This is how defining some profiles for the remote development looks like. Basically, you're allowed to specify the command which needs to run after the remote development setup completes. You can define a sync path, and here is one of two ways in which the platform can work. It can work with the files synchronized from your local into the container, because some developers prefer to use it that way, or it can work with no files on local and just have all the files and the Git included in the container running in Kubernetes. You can also specify the ports. You can specify overrides for environment variables and eventually the resources needed, because usually you need higher resources for development than for production. These are two other very useful tools under a developer's belt, not directly related to remote development, but somewhat related. So one is port forwarding. For example, if you have a database deployed in the cloud, it's usually not publicly exposed. That's a good practice. So you would forward the port on your local machine, and then you'd be able to connect using your local port. And the other is SSH for diving into a container and seeing what actually happens there. Like if you have logs that are written into files, although you shouldn't, or want to see environment variables, or want to install other dependencies, and so on. The last use case I want to touch upon is the ephemeral environments. So basically, this is the concept which supercharges environments as a service, because it introduces short-lived and disposable environments. Basically, you are now able to create environments as you need them and then discard them right after it's done. And this helps us prevent having state for environments and solves our controllability issues. So ephemeral environments can be many things. Usually they're implemented as preview environments, which ultimately means creating a new environment whenever a pull request is created. This is very useful for performing code reviews with an application running, not just looking at a huge diff and code. It can be used for testing later on, for interacting with stakeholders to preview the work, and you name it. And this is where the flexibility principle that we have defined really comes in, because Bunnyshell is able to meet teams exactly where they are. Even if you have no CI/CD in place at the moment, you can just literally flip a switch, or the toggle to create ephemeral environments, and it will work based on the webhooks from Git. You will have an environment created for every pull request. This can or cannot be deployed. It depends on you. Like if you have a pickup time of 2 days after a pull request is created, you probably don't want the environment running immediately after the pull request was created, and we'll start it manually. And probably this is the moment in which you ask yourselves, okay, this sounds nice, but how much is it going to cost? And the answer is that it depends, and it is also less than what you'd expect, because these environments can be stopped. So basically, when an environment is stopped, it does not consume compute resources anymore. It does not consume memory or CPU from Kubernetes, as the containers are deleted from there. And if you have a scalable Kubernetes cluster, it can scale down quite substantially. So there are a few things. An environment can be stopped and started manually on demand by a developer who is, I don't know, working on a bug fix, let's say, right? You are developing or working on a larger project, you have your environment there, a bug fix comes up, you stop your environment, your environment on which you're working now, and you start a new environment for the bug fix. So basically, you're still running a single environment, but it's a different one with no state. You don't have to stash your changes. You don't have to deal with database schema changes and so on. So going back to availability rules, these can be time to live. You can have environments stopped automatically after a certain period of time of inactivity, or you can have them set at a schedule, which you can define at a project level or define at an environment level. And the second way of deploying, basically implementing, not deploying, preview environments is to integrate with what you already have. This is an example for GitHub Actions, but it can be used the same for Jenkins, GitLab pipelines, and you name it, any other platform. It's ultimately code, and the Bunnyshell CLI can be leveraged from these actions to create new environments and then discard them. This is an example from Cilius, which is an open source e-commerce framework. They use Bunnyshell to have their preview environments created. And this is more or less how the interaction looks like from a developer's point of view. Basically, you create a pull request, and then Bunnyshell creates the environment and posts back a comment in the pull request with the URLs for the application, so you can access it. And you can then interact with the environment directly from here through comments. You can stop the environment, you can start it again, you can delete the environment or trigger a manual deployment by running some commands like /Bunnyshell semicolon deploy, something like that. And these are the reusable workflows. I'm not going to list them here, but they're publicly available, so anyone interested can take a look. They leverage some workflows which are maintained by Bunnyshell. So how do you actually adopt environments as a service? It's a step in which you must connect your input and your output. You must connect your Git repositories, optionally your container registries, And you should connect your Kubernetes cluster where you will actually perform the deployments to. Then you need to define your environment, fine-tune it, and decide what to automate or not. So we're nearing the end of the presentation. We have discussed about a few scenarios which are on-demand environments, preview environments created in an automated manner. We have discussed remote development with cloud environments, testing environments, and UAT environments. This can be all used for various purposes across the software development cycle. But environment as a service is not limited to software development teams. You have the ability to use it in sales, let's say to create automatically based on a calendar integration. You can create environments for demos that are about to happen and then destroy them afterwards. You can use them for training, for certain events. For example, we organized the hackathon and every developer there had access to the platform to create their own environments. It was all discarded after the hackathon was over. And you can create sandbox environments for, am I done? Sandbox environments for everybody else that wishes to integrate with you. This was it. These are the main benefits in which environment as a service can help your team. Basically, you can shift better code and faster and offer a great developer experience, which ultimately brings back the joy of developing in larger organizations especially. Thank you.
Thank you. So, questions? Come on, you must have one question at least. Okay, so let me ask you. No, I think they're just thinking which would be the best question. Let me ask you, which is the most common question that you get when you are talking with customers for the first time about your platform?
They're all over the place, but usually it's about how easy it is for them to adopt, to integrate with what they already have, because they're really scared that they invested like years of work and they won't be able to reuse that. Yes. This is the number one, and number two, it's related to costs.
Now provide the answers.
So I think I already touched, I hope I already touched pretty well this point in the presentation. Even if you have a full-blown CI/CD, Bunnyshell can be used to extend it through the CLI or through an SDK or through the public API. So integration is pretty easy, and a very common scenario we see here with our clients is for them to add preview environments and add environments for end-to-end automated testing. Like they create an environment, run tests, and then discard the environment within their pipelines.
Thank you for that. So any questions at this point? Okay, so thank you so much. We have a question there. As always, ladies are more courageous. Thank you.
Maybe one question related, how is this transforming the workplace? So what type of professional and what type of skills would you need to actually run this type of tool, let's say?
That's a great question. Actually, you don't need to be a software developer. Bunnyshell can help anyone, and environment as a service, as a concept, can help anyone within the organization which is related to product, and as I mentioned later on, even sales or I don't know, HR with trainings and so on. So basically it helps software developers being able to dev test, it helps QA engineers being able to test things and context switch, so no more dead times for them waiting. It helps product managers, stakeholders being able to preview the work and give early feedback and contribute early to how the product is developed. And basically, there's no more waiting until the end to give feedback and then redo the work, right? It's a very rapid iteration cycle here.
Thank you.
Thank you.
Thank you for the question. Any other question? Okay, so if we don't have any other questions, let us thank you, Sorin, for the presentation. Thank you very much.